Bismillahirrahmanirrahim. Welcome to the Inclined Thinkers. I am Sadiq Amar, your chemistry teacher. Respected students, आज हम चैप्टर नंबर 5 क्लास 9 केमिस्ट्री जो है उसको डिस्कस करने जा रहे हैं, जिसमें स्टेट्स ऑफ मैटर है। स्टेट्स ऑफ मैटर में जो है हम लिक्विड की जो स्टेट है उसको डिस्कस करेंगे। जब हम चैप्टर 5 में फिजिकल स्टेट्स को देखते हैं तो देयर आर 3 बेसिक स्टेट्स ऑफ द मैटर. One of them is solid, liquid and gases. The point of today's discussion is boiling point, explanation with graphical representations, factors affecting the boiling point. It includes the nature of the liquid, intermolecular forces, external pressure and the further freezing point and the comparison of the freezing point and boiling points of the liquid. So first of all, we will see what is a boiling point. Dear students, when the vapor pressure becomes equal to the atmospheric pressure or the external pressure is called boiling point. यानी वेपर प्रेशर और एक्सटर्नल प्रेशर जो है उसको एटमॉस्फेरिक प्रेशर भी कहते हैं। जब वेपर प्रेशर और एक्सटर्नल या एटमॉस्फेरिक प्रेशर जो है वो इक्वल हो जाता है तो उस वक्त क्या होता है, उसको हम बॉइलिंग पॉइंट कहते हैं। जब हम इसके प्रोसेसिंग की बात करें, जब भी हम किसी चीज को हीट अप करते हैं, जो टेम्परेचर प्रोवाइड करते हैं, प्रीवियस लेक्चर्स में भी ये रीजंस बताई गई हैं कि उसकी विद द इंक्रीज ऑफ द टेम्परेचर द काइनेटिक एनर्जी ऑफ द मॉलिक्यूल्स बिकम इंक्रीज with the increasing of the temperature. Its mean kinetic energy is directly proportional to the temperature. When we increase the temperature, its mean kinetic energy will also increase and vice versa. Furthermore, the kinetic energy of the molecules become greater or increase than the molecules of the number of the molecules which have more than average kinetic energy will escape or will get on the top positions. Its mean the molecules with more kinetic energy will try to excite themselves up to the upper surface of the liquid. So a point will reach when the vapor pressure of the liquid is equal to the atmospheric pressure. This point is called boiling point. So we are discussing now and we are seeing the wording of the boiling point, that is the temperature at which vapor pressure of a liquid become equal to the atmospheric pressure or any external pressure is called boiling point. Now we are going towards the explanation. As we have already discussed that when the liquid is heated or temperature is provided to the liquid, its molecule gain the kinetic energy. The number of the molecules which have the more than average kinetic energy increases. More and more molecules become energetic enough to overcome the intermolecular forces. Due to this, the rate of the evaporation increase, then the results in the increase of the vapor pressure until a stage reaches where the vapor pressure of the liquids become equal to the atmospheric pressure. The liquid starts boiling and this point is called boiling point. Now we are seeing the graphical representation. Dear students, we have the 3 liquids: ether, alcohol and water. We are seeing the boiling points of these 3 liquids. First of all, we see the ether, then alcohol, then water. First of all, we are seeing the temperature at 0 degree centigrade of the ethyl alcohol, diethyl ether and water. First of all, we will see the increase of the vapor pressure of the ethyl alcohol and water with the increase of the temperature. At 0 degree centigrade, the pressure of the ethyl alcohol is 200 mm of Hg, ethyl alcohol of 25 mm of Hg, while the atmospheric pressure of the boiling point of the water is 5 mm of Hg. But with the passage of time, we are providing the temperature. With the increase of the temperature, its vapor pressure will also increase. So when they are heated, the vapor pressure of the diethyl ether increases rapidly and become equal to the atmospheric pressure at 34.6 डिग्री सेंटीग्रेड. दिस इज पहले ये 0 पे था और अब क्या हुआ, जैसे हमने इसका टेम्परेचर इंक्रीज किया तो क्या हुआ कि इसका जो टेम्परेचर था वो 34.6 डिग्री सेंटीग्रेड हो गया. ठीक हो गया. while the vapor pressure of the water increases slowly, जबकि वाटर जो था उसका वेपर प्रेशर जो था या उसका बॉइलिंग पॉइंट जो था वो स्लोली इंक्रीज कर रहा था. उसकी रीजन क्या थी कि उसके दरमियान में स्ट्रॉन्ग इंटरमॉलिक्यूलर जो है वो फोर्सेज होती हैं. While the vapor pressure of the water increase slowly because intermolecular forces of the water are stronger. The figure shows the vapor pressure increase very rapidly when the liquids are near to the boiling points. In other words, we can say these are the three liquids, that is ether, alcohol and water. We are providing the temperature, or we are increasing the temperature regularly or increasingly. So the vapor pressure depends upon the intermolecular forces and boiling, as well as the boiling point also depends upon the vapor pressure, as water has a stronger intermolecular forces. So what boiling point of the water is greater as compared to the alcohol and ether. So the boiling point of the water is 100 degrees centigrade, alcohol is of 78 degrees centigrade, and ether is 34.6 degrees centigrade. These boiling points tells us the rate of the intermolecular forces. The liquid which with higher boiling point, it's mean it has a stronger intermolecular forces like water, and the ether with low boiling point shows that it has a weaker intermolecular forces. Now we are seeing the factors affecting the boiling points. First of all, the nature of the liquid. As we are familiar that there are two types of the liquids, like polar and non-polar. As we are familiar that polar molecules are the polar liquids as a positive as well as negative charge. It's mean they have electrostatic force of attraction. So due to these opposite charges, they have strong intermolecular forces. The rate of the boiling point of the polar liquids will be high as compared to the non-polar, because non-polar have the weaker intermolecular forces, so they can boil very easily or very sharply, but boiling point of the polar liquids are higher as compared to the non-polar. G students, the next point is intermolecular forces. As I have mentioned in the key that intermolecular forces are directly proportional to the boiling points. It's mean with the increase of the intermolecular forces, the boiling point of the liquids will also be a high. The intermolecular forces are strong. It's mean there is a lesser distance between the molecules. So it is not easy to break the molecules. So more energy is required to break the bonding or break the intermolecular forces. Therefore, with the increase of the intermolecular forces, the boiling point of the liquid will also be increased. So we can say that intermolecular forces and the boiling point are directly proportional to each other. And this trait of the directly proportional mean there is a same type of change on the both sides. If the intermolecular forces are stronger, it means there is a greater in the boiling point, and the vice versa. When we are seeing the wording of this slide, that is intermolecular force play a very important role on the boiling points of the liquids. Substances having the stronger intermolecular forces have high boiling points because such liquids attain the level of the vapor pressure equal to the external pressure at the temperature. When we are seeing the graph, there are three liquids given and mentioned on the graph. Number one is ether, number two is alcohol, and number three is water. Water has a high boiling point. It's mean it has a stronger intermolecular forces. And beyond this, alcohol has 78 degrees centigrade boiling points. It's mean it has a greater intermolecular forces than the ether, but lesser intermolecular forces than the water. The next one is the external pressure. As I have mentioned, the condition that vapor pressure depends upon the temperature, or vapor pressure depends upon the boiling points. We are seeing that vapor pressure is directly proportional to the boiling point. With the high temperature, the vapor pressure is higher than at the low temperature. It's mean when the vapor pressure is high, it's mean boiling point will also be a high. Therefore, we use the pressure cooker for cooking the foods to block the external pressures, or to break the external pressure, or to you can say minimize the external pressure for the purpose of the cooking. At high temperature, the vapor pressure is higher than at the low temperature. As elevated temperature, the kinetic energy of the molecule increase enough to enable them to vaporize and exert pressure. It can be increased by increasing the external pressure and vice versa. This principle is used in the working of the pressure cooker. We are seeing that when we are providing the temperature, the kinetic energy of the molecules become increased. When we are applying the external pressure, it's mean boiling point of the liquids will also increase, because with the increase of the vapor pressure, the molecules come closer and closer, so the boiling point will increase. Therefore, we can say that the vapor pressure is directly proportional to the boiling point. So, next is freezing point. What is a freezing point? We know that there are the 2 to 3 types of the liquids we have discussed in this chapter. When we are cooling the liquid, it's mean basically we are decreasing the temperature, and with the decrease of the temperature, the kinetic energy of the molecules become lower and lower, and with the decrease of the temperature, the kinetic energy molecules become lesser and lesser, so the molecules come close to each other. In as a result, the intermolecular distance become decrease, so we can say that the kinetic energy of the molecule become increase and increase. At this temperature, the liquids and the solid coexist in the dynamic equilibrium, and this is called freezing point. We can say when liquids are cooled, the vapor pressure of the liquids decrease and stage reaches when the vapor pressure of a liquid state becomes equal to the vapor pressure of the solid state. At this temperature, the liquids and solid coexist in a dynamic equilibrium, and this is called the freezing point. Students, we are basically comparing now the freezing points and boiling points of the some common liquids like diethyl ether. The freezing point of the diethyl ether is minus 116 degrees centigrade, and the boiling point is 34.6, as we have discussed in the previous slides. Furthermore, the ethyl alcohol has a freezing point minus 115, and the boiling point is 78 degrees centigrade. We have already discussed in the previous slides. And the third one we have discussed is the water. Water has a freezing point of 0 degrees centigrade, but have a boiling point of 100 degrees centigrade at room temperature. But at the higher temperature, like at the higher places or in the hilly areas like Murray and etc., the boiling point of the water will be 98 degrees centigrade, because at that place the external pressure become lesser, so the boiling point will also be a lesser. The next one is N octane. The 57 minus 57 degrees centigrade will be the freezing point, and the boiling point of the N octane will be 126 degrees centigrade. And the fifth and the last one, the liquid is acetic acid, that is organic acid. The freezing point of the acetic acid is 16.6 degrees centigrade, and the boiling point of the acetic acid is 118 degrees centigrade. रिस्पेक्टेड स्टूडेंट्स, थैंक यू वेरी मच। डियर व्यूअर्स, आप जो है वो कमेंट भी पास कर सकते हैं अपने, आप जो है वो क्वेश्चन भी पूछ सकते हैं। बेहतरी के लिए अगर कोई कमेंट करना चाहें आप कमेंट भी कर सकते हैं। पहले भी बता दिया है कि इनक्लाइंड थिंकर्स जो है उसने अपनी वेबसाइट भी लॉन्च कर दी है, आप जो है वहाँ से भी लेक्चर देख सकते हैं। थैंक यू वेरी मच।